Okay, 11.3. This is the last of the new material that is going to show up on the final. This is the last of the new material for which there's homework. All right, there is a section called ANOVA, which we will do, but it doesn't include any homework. So, you know, you're just going to watch it and find out a little something depressing about the planet. Okay. All right, but here we are. We're doing a drug trial. And so I'm a drug company, and I give some people the drug, and I give some people the placebo. And a lot of the people who took the drug got better, and a lot of people who took the placebo did not. And so maybe my drug works. Now, if I was a drug company, what I really don't want to see is that this chart looks like this, where it doesn't matter whether you took the drug or the placebo, and you either got better or you didn't. No one knows why. Okay, but it definitely doesn't have anything to do with the drug. That I don't want to see. If I'm doing a drug trial, I want to know that, like, people with the placebo, they're not getting better. People with the drug, they are getting better. Are these numbers good enough? I mean, is that enough of a difference? You know, it's not as wishy-washy and boring as that, but maybe it's not good enough. Okay, so I need a test to tell if things are a little bit good or not good enough. All right, so basically I'm trying to make sure that my chart isn't some sort of everything's the same kind of thing. Now, in section 11.2, the goodness of fit, we were trying to make sure everything was kind of the same as one of these boring situations. Here, we're hoping for something to be really good. Everything's different. Not everything's the same. That was like, oh, reject or fail to reject is all the same. We want to know, is it different? So we're looking for a chi-squared mine. We're looking for a big one. Okay, before we were looking for a small one because we didn't want all the numbers to fluctuate too much out of the center. Here, I want big numbers. All right, chi-squared mine. Okay, could do it by hand. I had to do 11.2. There is no way to do it anyway besides by hand because calculator doesn't have it. But on this, the calculator does. Okay, because this, nobody ever does goodness of fit, but everybody does contingency tables. There's drug companies everywhere doing this all the time. All right, so I go into matrix. Now, matrix on some people's calculators is a second function. On mine, it's a first function. It's like right there. Okay, and then I go over to the word edit. And I need to say that I want it to be a 2 by 2 matrix. So I hit 2, enter, 2, enter. I need that every single time because I need to put in 4 numbers in a little 2 by 2 box like that. So I'm putting any numbers in there yet. I just put in that. And then I go 48, enter, 32, enter, 17, enter, 41, enter. All right, now I've made my entire matrix, so then I second quit to get out of there. All right, and then I go into stat, tests, chi-squared test. All right, we've been dealing with that chi-squared chart forever, and you've never told me there was a chi-squared button on there. This chi-squared button only does matrices. It doesn't do any of the other things we did with chi-squared. So there's no way to force this chi-squared test button to do something from section 11.2. It only does section 11.3. Anyway, I go in there, and it says observed, and then it has A written down, which is because that's actually where I just put this 2 by 2 matrix. If you put yours in matrix C, you better say C right here. It's where it's going to go looking for a matrix. It's in matrix A. Chances are you did matrix A, was the first one. And then underneath that, it says expected. And then it says matrix B. Wait, I didn't put anything in matrix B. You don't have to, okay? It's going to take those observed and calculate the expected on its own. So why does it even tell me that then? Just because if you had something really important, some matrix you need to save for the rest of your life and it's stored in matrix B, you better go move it because this is about to overwrite matrix B with what it gets when it's doing its calculations. So you just need to know that. And then you just go down to calculate. Okay, and it says 12.6. Actually, I think it said 12.71. That's because on the notes I was calculating it by hand the old-fashioned way, and then in my calculator slightly different. This is like a chi-squared mine from the previous section. That's a measure of how big the fluctuations are away from some sort of central number like that. Okay. Well, is that big enough? How do I know? I mean, that wouldn't have been big enough in the last problem. I had like a huge chi-squared chart. But I get a new chi-squared chart. Okay, degrees of freedom 1. My calculator even said degrees of freedom 1. That's because way down here on the bottom of the chart, it says 4 contingency tables with R rows and C columns. So you go, well, it's 2 rows and 2 columns. So you go 1 times 1 equals 1. Okay, and it's just a good hint. It says it right there at the bottom of the thing. That's what I was supposed to do. 2 minus 1 times 2 minus 1, 1. Okay, so I'm supposed to go down to 1 under 0.05, 3.841. If you really did do contingency tables for a living, then you would know this number, 3.841. Because you'd always end up with a 2 by 2 matrix. You'd always be doing like a drug and a placebo or a program or no program or something. You'd always be testing one thing against some sort of baseline. So it'd always be a 2 by 2 chart. And so every time you went to look at the chart, you'd look under 0.05 because it's industry standard, and you'd look under degrees of freedom 1. You'd end up there every single time. So guaranteed, drug companies have got your 3.841 memorized. They don't look it up on a chart. It's the same number every single time you do it. Anyway, 12.71 is bigger than 3.841. Okay, if I did this 30, 30, 30, 30 as my matrix, I'd get like chi-squared minus 0 or something. I mean, there's no fluctuation in that. This is a measure of how wildly things are fluctuating in this chart. And it's bigger than the cutoff. So, yes, something important is happening in this chart. Scurry back to the chart. Yes, it looks like the drug is working.